Welcome back. Today we're going to be doing some one-step inequality word problems. So before this video, make sure you watch the one about solving one-step inequalities in general, as this video is going to be doing that as well, but it's also going to focus on how we can take a word problem and make it into a one-step inequality that we can then solve. So essentially, just a reminder of how to solve inequalities in general, though, is that we would solve them the same way we solve one step equations, the only difference being that when multiplying or dividing a negative sign through an inequality, we must flip that inequality. So here's the first example. It says, a class is working on a project that requires at least 200 hours of work. If each student is expected to contribute 5 hours, how many students need to participate to meet the requirement? So first, I'm going to define my variable. Let's let x represent the number of students. Because essentially what they're saying is here we need 5 hours times the number of students, because each student who works on the project would be expected to contribute 5 hours. So 5 times x, which is our number of students, would give us the total number of hours needed here. And that must be greater than or equal to 200, because the project project requires at least 200 hours of work at a minimum. More is fine too, but 200 is our minimum. So therefore, 5 times the number of students, which is x, must be greater than or equal to 200. Now I need to solve this inequality. So basically, to solve it, I'm going to divide both sides by 5. If I divide 5 by 5, I just get 1. So 1x just gives me x. And then 200 divided by 5 is going to be 40. And so therefore, in terms of how many students need to participate, well, the minimum is 40 students. Its x needs to be greater than or equal to 40. So a minimum of 40 students must participate, but more could also do it as well. So I'm going to answer this by saying at least, or a minimum of, 40 students must participate in order to meet the requirements. All right, let's try one more. A concert hall has a maximum capacity of 500 people. If 100 tickets have already been sold, how many more tickets can be sold without exceeding the capacity? Okay, so for this one here, we know that 120 tickets have already been sold, plus how many more tickets will be sold, we don't actually know, right? It's going to be x. We're going to let x represent the number of tickets that will be sold in the future but have not yet been sold, so not part of the 120 that already have been sold. And that's got to be either less than or equal to 500. Now, I get that preferably it would be equal to 500 so that they sell out as many tickets as possible, but it's also possible they could sell less tickets overall than 500 and it just wouldn't be a full night that night, and that would work too. So 120, so tickets that have already been sold, plus the number of tickets that will be sold in the future can't exceed 500, must be less than or equal to it, because if it does exceed 500, then we won't have enough seats for everyone. Some people will be without a seat. So how can we solve the inequality? Well, what's the opposite of adding 120 to both sides? It would be subtracting it. So I'm going to be subtracting 120 from both sides. These are going to cancel, and we're going to get x is less than or equal to 380. So in terms of how many more tickets can be sold without exceeding the capacity, the answer is 380. So therefore, up to 380 more tickets can still be sold without exceeding the theater's capacity or the concert hall's capacity. All right, if you have any questions about this example or the previous one, feel free to leave those down in the comment section, and we'll see you for the next one.